Hello from the Forcetronics YouTube channel. Welcome to using the ESP-Now communication protocol to create a dynamic ESP32 wireless network. And this is part 2 in a 3-part series. As I mentioned in part 1, if you want to access or download the code for this video series, as well as access other exclusive content, check me out on Patreon. It's only $3 to join. If you don't want to pay the $3 to join, you can always take screenshots from this video and write down the code yourself. All right, let's jump in. So as I mentioned, this is a 3-part series. This is part 2. In part 1, I went over what ESP-Now wireless protocol is. I talked about how we're going to use it, why we need MAC addresses, and also the formation of our dynamic network and what I was defining as a dynamic network. I'm more excited now for part 2 and part 3 because we actually start diving into demos and code. So without further ado, let's just go ahead and do that. So I'm going to start out with a demo, a pretty simple demo, right? And so we're going to look at some code that does a basic implementation of ESP-Now, as well as some functions to deal with MAC addresses. And the idea is this code is a simple example, but we'll use this code as a foundation for part 3. Now I'm showing you pictures of 2 different boards that have ESP32 modules on them. In fact, ESP32 room modules on them. The one on the left is going to serve as our primary for our second example, our primary node. And the one on the right is going to serve as our secondary node for this basic example. Of course, when we get to part 3, we'll be able to support up to 20 secondary nodes. You know, if you're a fan of my content, you'll notice the board on the left is the Forcetronics ESP development board. Check out my other video series where I talk about some of the design of these circuits. And also I have content for this on my Patreon page. And then the one on the left is just a generic ESP development board that I got on Amazon. Now they're going to communicate back and forth. And in my simple program, what I'm going to have them do is, the way you communicate using ESP-Now is a board for the primary board to talk to the secondary board, we have to know the secondary board's MAC address. So in our simple example, the secondary board is going to print out its MAC address to the serial monitor. The primary board is going to ask for a MAC address to be entered in its serial monitor. We're going to enter the secondary's address in the serial monitor. Then the primary is going to talk to the secondary and send the secondary its MAC address, so that way the secondary can talk back to the primary. So I hope that makes sense. That's what we're going to show in our basic example. Okay, so just how we had the primary on the left and the secondary on the right, the serial monitor, so we're looking at an Arduino serial monitor. And the one on the left, COM19, is the primary unit, and the one on the right is the secondary unit. And I started the code running, and each of them printed out these messages. So basically, the primary is asking for you to enter a MAC address. And if you're not familiar with a MAC address, I'd encourage you to look it up. But a MAC address is 6 bytes of data. Each byte of data is separated by commas. And each byte of data should be written in hex format. And also, if your device has a single-digit byte, you want to precede it with a 0. So if it's an 8 or an A, you want to put 08 or 0A. All right, and then the secondary unit, it wants to connect to a primary unit. So the primary unit wants to connect to the secondary unit, and the secondary unit wants a primary unit to connect to it. So I have the secondary unit configured to print out its MAC address. So it starts its ESP communication, it prints out its MAC address as a string. I then convert that to a byte array and just print it out as 6 bytes. Now the secondary at this point is looping, waiting for data to come in, to read data. And it's expecting data from a primary unit, and it's expecting the payload to include the MAC address, so it can talk back to the primary. And the primary is just looping, waiting for a MAC address to be entered. So let's do it. So we're going to enter this MAC address from the secondary unit. So we got C8, comma, F0, comma, 9E, comma, 52, comma, 89, comma, and 4C. I'm going to press enter. So we see both things, stuff happened on both sides, right? So we know there's some communication because typing in the MAC address here triggered some activity here. So what happened? Well, first, the primary unit acknowledged the MAC address. And in this simple example, I don't do error checking. So if you If you enter the MAC address incorrect, you'll see it just trying to keep communicating and nothing will happen and you'll need to reset the unit. So what I did is I have it print out the MAC address so you can see that you typed it in correctly. So you can see I typed in the MAC address correctly. It then created an ESP-Now peer, right? And that's what ESP-Now communication protocol calls a unit that's entered in its network, we'll say. And once again, after this demo, we're going to look at the code. Then it says it's attempting to send the primary MAC address, so this unit's MAC address, to the secondary node using ESP-Now communication. It then sends the information and it gets an acknowledge packet so it knows that it sent it successfully. Let's go over to the secondary unit. So the secondary unit first printed out its MAC address. It then looped waiting for the primary to reply. It got a reply from the primary. It then decoded the payload and got the primary node's MAC address, right? And the reason the primary node has to send its MAC address is because the secondary node can't talk to the primary without knowing its MAC address, right? So here we see the primary's MAC address, and then it's going to attempt to add it at the primary as a peer, right? Because to talk to a device on the ESP-Now network, you have to add it as a peer. It successfully adds it as a peer, and then it sends a reply. And the reply is simply just a 1, right? So if we jumped back here, now this was looping, after it sent the MAC address, it was looping, waiting for a reply. Once it detected there was a reply, it then prints out what the secondary node sent, which was a 1. And then the secondary node gets an acknowledgement packet so it can say, oh, we know that communication was successful. All right, let's look at the code, first for the primary and then for the secondary. A lot of the code between the two will be the same, so I'll spend more time on the primary sketch and then we'll look at the secondary sketch. Okay, here's my primary sketch, and I know this is going to be a lot of code by the time we get to part 3, so I have sort of my main part of my sketch with the setup code and the loop, and then I have different classes. I have a class for accessing the MAC address and storing the MAC address, and then I have a larger class called primary com, which is just a wrapper class for the ESP-Now communication. So I think I'm going to start with the primary com class because that is the ESP-Now wrapper. So we can kind of see how the ESP communication is set up first, and then we'll look how it's implemented in the main sketch. I also have a definitions file. I just put my macros in there. So here's the header file for my primary com class. So this is just the function definition. So I'm not going to spend much time here. I may jump back here. But if we go here, we can see right away, of course, we're calling the header file, but we're also calling the ESP-Now library, right? So I didn't have to download this library. When you download the board manager for ESP32, you get this library. And then I had to include its Wi-Fi library because we have to use that as well. These first couple variables are flags. These first two, one is the R flag, which is the receive flag. It goes true when there's new received data. And then I have the send flag. The send flag goes true when data was sent successfully. And then I just have this simple variable for hold the data that the secondary unit's node sends back to us. Here's my constructor for the class. These first two functions, these are described, how to declare these are described in the ESP-Now documentation. So I can pick whatever name I want for this function, but the arguments are defined mainly by the ESP-Now documentation. And so here we have the MAC address, and then we also have a ESP-Now specific variable, which represents the status of sending data. So this is what they call a callback, or you might think of it like an interrupt function. So whenever I send data, I never call this function. Whenever I send data, this function's automatically called, and that way I can set my flag to true. You can do whatever you want in this function, but the way I'm using it is and once again, I'm using a macro from the ESP-Now library. If the status is successful, I mark the send flag as true. And if not, the send flag remains false, so I know it was not successful. So that's how I'm using this send callback function. Then I have a receive or data received callback function. Once again, that ESP-Now defines the arguments that are supposed to be in here. But you can see what some of them are, right? Some of them are a MAC address. Some of them are a pointer to the incoming data, which can't be larger than 250 bytes, as we discussed in part 1. And then this is the length of the data in bytes. So in data received, I use the memcopy function, which is a built-in function in C and C++. And what I do is I copy the pointer of incoming data to this byte of data up here, because I know the secondary. One thing you kind of have to know is what type of data the units are going to send between each other. So I know it's going to send just a byte of data. I reference it, so it turned it into a pointer, and it copies the memory location of incoming data based on the size to this variable. And then what do I do next? I mark the receive flag as true, right? Because this callback function is asynchronous, so I don't know when it's going to activate. So this flag allows me to loop in my main sketch, and once it goes true, I know there's data. Okay, and then in the secondary side, this callback function will be ready to receive a MAC address, right? So here's my initiate primary comm, and this is where I set up my communication and my ESP-Now communication. So the first thing I do, and this is why we need the Wi-Fi library, is we need to make sure that the ESP32 is in Wi-Fi mode as a Wi-Fi station. Then we call the ESP-Now init function, right? And we once again use a macro to see if it properly initialized. If it doesn't, this function returns false, so we know that something went wrong. And then if it does, it returns true. Now I mentioned the callbacks. These ESP-Now functions are where you register the callback, right? So I can pick whatever name I want for the callback, and then I'm telling these functions that this is the callback function or the interrupt function to execute whenever you receive data. And this one's for executing when we send data, whether it's successful or not. Okay, so that's something you obviously need to call in the beginning. This is where we create a peer, right? And you can't talk to any other nodes, even if you know your MAC address, until you register them as a peer. So this is a wrapper. So I use memcopy again. So I have to create a peer. And how do you create a peer? You need the unique identifier, which, as I mentioned before, is a MAC address. They want the MAC address as a byte array or a byte pointer of the 6 bytes of data that make up the MAC address, right? It doesn't worry about the colons. It just wants the individual 6 bytes. I have a macro that's size 6, so I copy the address over to a structure for peer info, which I declared on the header file. And then since it's a structure, I say .peer address. So this is creating my peer. I then do some other settings for the peer structure, which is channel 0 and encryption false. Remember, encryption's great. So in the real world, you probably want to use it, but if you use encryption, you can support less nodes. If you don't use encryption, you can support up to 25, or not 25, 21. There's other peer settings, but you can go to the documentation to see them. Now we're going to add the peer. So we have a structure of a peer. We declared a peer variable, and then we add it. We register it as a peer in the ESP-Now library. You could also do, what we'll do in the future is we'll have a peer array, right? Because right now we're just adding one peer. If something goes wrong, we return false. If everything's fine, we return true. Then we need to send our primary MAC address, right? That's the payload we're sending to the secondary node in our simple example. So the input to this function is the secondary's MAC address, because we need to do that to send data. And then also the primary's MAC address, because that's our payload. That's what we're sending. So I call an ESP-Now function. I can then use an ESP-Now variable that I declare to capture the error state. We're not really using the error states that much, but in the other one, we'll use error states. So if something goes wrong, we can detect what went wrong. But this is their send function. Once again, there's the MAC address of the device we're sending to. Another thing is I can just get it from the peer that I registered, but we'll see that in part 3. Here's the primary MAC address, which is our payload. And then this is the length of our payload, which is 6 bytes because it's a MAC address. We send it, we check to make sure that there was not an error. Once again, it'll return various errors. We're just checking if it's okay with no errors. If it's not, we return false. If it is, we return true. Then these last functions are the flags, right? So I don't want to call those variables directly in the main part of the sketch, so I just have functions. So If I want to check if data is received, I check the receive flag. If I want to clear the receive flag, so after we get data, it goes true. We see that we got data. We want to clear it to false so we can detect next time we get data. So that's what's happening here. We do the same thing for the send flag, right? Get send flag, clear send flag. And then this is also to get that 1 byte variable of the payload. Okay, the other function, and this class is the MAC address class. And here's the header file. And then here's this file. And this class is much more simpler, and it's actually the same for both the secondary and primary. And I'm not going to go through this whole class because some of the functions I put in there that are meant to be for part 3, and I may change them a bit. But the main thing you should be interested in is this first one where we initiate get MAC. Because this is where we get the MAC address. So if you want to know your secondary unit's MAC address, you can use this function right here. And we need the Wi-Fi library for this, but Wi-Fi.MAC address. So this is going to return the MAC address of the ESP32 you're using in a string format. We then take it from a string format to a char array, and then I use this function. So this is the other function we'll use from this class right now that converts I say string, but really it's a char array, to a array of bytes, because that's how ESP-Now wants it. And then I also return the string so you could print it out if you want. And then that function that does the conversion, that's right here, right? So you get an array of chars, right? So remember, a MAC address is 6 bytes that's separated by colons. So what we want to do is we do a loop to loop through all the bytes, but we want to skip the bytes that are colons because we don't care about those. Once we get the individual numbers, we detect if it's a decimal number or a hex number. We then convert it from an ASCII 2 variable to a real decimal value. That's why I'm subtracting 48 to get the real number valuable. So I'm converting from a char to a number. Then here I add the 2 bytes together, right? Because I'm going through the digits separately, but then I turn them back into bytes. And anyway, and then I load them into this byte array and store this. Or I shouldn't say store this. I copy it over to a local input array. Okay, hope that makes sense. So that's how we're handling the MAC address as well as the ESP-Now communication. Now let's go to main. So you can see I'm calling my 2 classes that I created, the MAC handler. I have my definitions where my macros are, and then I have my primary com class. I declare objects to the classes, the MAC handler and the primary com, which is our ESP-Now wrapper. Now remember, you saw this on the serial monitor, so we can kind of, if you remember what happened on the serial monitor, we can kind of see the flow here. So one thing I do is I set a pin, and I use my macro, Mac pin, which I have it set up for pin 26. I set it as an input pull-up, because what I do is I make it so you can choose whether you want your device to print the MAC address out to the serial monitor, or if not. I had this pin pulled low on the secondary, so it printed out its MAC address. On the primary, I did not, so it did not print out its own MAC address. I then initiate the ESP-Now communication, and I get a Boolean back to see if it worked. I do a large delay here just to give myself time to open the serial monitor. I start my serial communication. Now, I like to define my Arduino serial communication functions as macros, and I do that in definition.h. The reason I do that is because a lot of times when I'm starting development, I like to use the serial monitor to debug and to monitor how things are working. But then at the end, I may want to get rid of the serial for the finished design, and this, using it as macros, allows me to get it in and out. So if you don't understand what I said, it's fine. Just replace these with the standard Arduino serial commands. So I start my serial communication. I check if my init for my ESP-Now worked. If it didn't, I tell you something failed, and I loop forever because basically there's no point in going on. So you got to check what's wrong. If it worked, I print it out letting you know this is what we saw on the serial monitor. Remember, we looked at the MAC address class. So I get my MAC address as a string. I get a local byte array that I'm going to hold my MAC address as a byte array. And then I convert the string MAC address, which is stored as a global variable in the class, and I convert it to a byte array. And then I pass in my local byte array, which once again is a pointer. An array and a pointer are the same thing. So I'm really passing in the memory location. So it copies the memory location of the byte array from the class to the local byte array. Here's what I was talking about printing out the MAC address. So if this digital pin is low, it prints out the MAC address. It wasn't for the primary, but it was for the secondary. And notice when I print it out, I define it as hex because that's how we want to see it, not as decimal. Now here's what you saw in the serial monitor for telling us to enter the MAC address, right? We're here, this is the serial printout telling you to enter the secondary node's MAC address. I then do a loop waiting for serial available to be true. So this is what we were waiting for when we came to the MAC address. We're just looping here. Once serial is available, this becomes true. We break out of this loop. We then read the serial string into a string variable. I then use this standard Arduino function to trim the string variable. So what this does is it takes out any carriage returns, end line characters, or spaces. So we just have the MAC address string. I then store the MAC address. And then using the MAC address class, I then do a local byte array again, and then I grab that MAC address from the byte array. And I guess I didn't show this function in the MAC address class, but all this does is store it in an array that can hold all the MAC addresses for the secondary units. We'll go into more of that later in part 3. So then I print out the secondary's MAC address so you can see that you entered it right. Then I add it as a peer, right? So here's that MAC address array, and I'm adding it as a peer. If it works, I say added a peer. If it doesn't work, I say failed to add a peer. Then I have a do while loop. So this is where we're trying to send the secondary unit our MAC address. So we'll keep trying this over and over until it works. And so we can check if the send works with this done boolean variable. And then we can also use our flag, our send flag, because if our send flag is false, that means it didn't work. So we can have two different types of sends that fail. We can have a send that fails just because something went wrong with the function or something was not set up correctly. We can also have a send that fails because we sent something, but we got no acknowledgement. So that's why I'm checking two different variables in this while loop. Once they're both true, then it was successful. So then I break out of the loop. I say that the MAC address was sent successfully. I clear my send flag, right? Because I want that to be reset. Then the primary goes into waiting. So now it's going to wait for the secondary to reply. So what are we doing? We're monitoring that receive flag. It's false. When it goes true, that means that callback function executed and we got data. First thing I do in this if function is I clear the receive flag. I then print out that we got information from the secondary node. And what do? I print out that function that gets that byte of data, and that byte of data should be a 1, which it was in our example. So that's the foundation for the primary code. Let's look at the foundation for the secondary code. Okay, the secondary code's very similar. I'm not going to go into the MAC classes because it's the same. I have a definition file. The secondary COM is our wrapper for the ESP-Now communication code. It's pretty similar, right? We have the flags. We have a variable instead of a byte. It's an array to hold our primary MAC address. We have our callbacks. We have our init function. We have the ability to add a peer. And then we can copy the MAC address to a local array or pointer variable. That's what this function does. And then we want to send data to the prime, right? So this is very similar to sending the MAC address, except we're just sending 1 byte of data, right? But works the same way. And then, I should show you I'm sorry, I skipped over it too quick. The data received function, that's our callback function. Instead of copying a byte of data, we're copying the MAC address. So this macro means 6 bytes of data, and we're copying it here and we're setting our flag. So we go to the main function, very similar, right? We're setting up our classes, we set up our pin, we do a init, we do a short delay, we start our serial communication, we make sure the init worked. Here, the secondary node, this is going to be pulled low, so it's false, so it prints out its MAC address. That's how we copied it. We saw it on the serial monitor and copied it over. Then the secondary just enters a loop, and it's going to loop until its receive callback flag goes positive. We clear the flag. We say we receive the MAC address. We get a temporary byte array. We get the MAC address from our copy primary MAC address function. We then print it out in hex to show that we got the primary node's MAC address correctly. We add it as a peer. We then send our data to them. There's just one byte of data that's true or one. We do a do while loop, so we keep sending it. If it's not successful, then once it's successful, we clear the flag and we're done. So that's it for this simple example. In part 3, we'll build on this. What I would ask for part 3 is remember some of the functions, the ESP-Now functions we went over, because we may not go over them in as much detail in part 3. Okay, that's it for part 2 of using the ESP-Now protocol to create a dynamic ESP32 wireless network. In part 3, we'll finish off the code for our network and we'll demo it. If you have any questions for part 2, use the comment section. And if you want to add anything, also use the comment section. Thank you for watching, and see you back here for part 3.